Good morning, everybody. On behalf of the Ontario Vehicle Innovation Network, the Ontario Ministry of Transportation, and Metrolinx, I'd like to welcome you all to today's Ontario Smart Mobility Readiness Forum. We're delighted that so many of you could join us today. For those who don't know me, I'm Rad Kadri and I head up OVIN. OCI's work takes place on traditional Indigenous territories across the province. We acknowledge that there are 46 treaties and other agreements that cover the territory now called Ontario. We are thankful to be able to work and live in these territories. We are thankful to the First Nations, Métis, and Inuit peoples who have cared for these territories since time immemorial and who continue to contribute to the strength of Ontario and to all the communities across the province. Today's forum will focus on a very timely topic, vehicle to everything, V2X communication pilots. As connected autonomous vehicles come closer to being ready for public roads, it is essential that they are effectively able to communicate with all types of infrastructure and moving objects that they may confront. And to ensure this, V2X pilots have been making some great headway across our province. Today's speakers will shine some light on some of the key lessons learned and takeaways from such initiatives. We hope that today's presentations will support your work by providing into how to deploy V2X communication technologies across your own communities. I would like to welcome Associate Minister of Transportation, Stan Cho, who will provide some opening remarks for today's forum. Mr. Cho.
Good morning, everyone. It's a pleasure to virtually join the municipality and transit agency representatives here today. The Ontario Smart Mobility Readiness Forum is an exciting opportunity to learn more about how innovative transportation technologies will transform the way people travel and how it will impact municipalities and transit agencies across Ontario. Our government is committed to building Ontario, and when we talk about innovative transportation solutions, it's crucial we have infrastructure in place to support these inventive ideas. That's why we've committed over $148 billion to expand Ontario's infrastructure over the next 10 years. Our plan includes more than $22 billion to support the planning and construction of highway expansion and rehabilitation projects across the province. This includes building Highway 413 to tackle gridlock across the GTA because getting people from point A to point B is essential to building a province that works for everyone. We're also building the new Highway 7, which will connect the fast-growing innovation hub of Kitchener, Waterloo, and Guelph and provide relief to Highway 401. This fiscal year alone, we're investing $2.6 billion to expand and repair provincial highways, roads, and bridges. Combined, these investments are estimated to create or sustain nearly 16,000 direct and indirect jobs. This is great for municipalities and great for people. Our government recognizes new and emerging transportation technologies have the potential to change the way we move, make transit safer and more efficient, and, of course, environmentally friendlier. And we need to be ready for this change. To make public transit a top choice for people, municipalities and transit systems will need to identify and harness technologies to improve their services to current and prospective riders. This could include app-based innovations, automation, and, as a topic of today's forum will explore, vehicles to everything technology. To support Ontario municipalities and transit agencies, our government is developing a transit technology toolkit for municipalities, which will include information on the latest transit tech being used around the world. Our toolkit will outline the ways new transit technology has the potential to make travel better, easier, and more efficient, with a particular aim to give smaller, rural, and Indigenous communities the tools they need to implement innovative transit solutions. There are so many exciting innovations happening in the world of transit technology, from dynamic routing and scheduling to vehicle connectivity and electrification. There's also a wide range of improved customer-facing tools like real-time arrivals, trip booking, and fare payment. Our toolkit will provide communities with the know-how to implement many of these innovative approaches. Our government is also getting our roads for the physical and digital infrastructure that will be required for connected and automated vehicles. Through pilot projects underway on our roads, we're gaining the technical expertise that will be required to set up Ontario's infrastructure for the future of travel. The Ministry of Transportation staff presenting later today will share more information about these exciting projects. Ontario's population is expected to grow by about 30% over the next 20 years. And as that population grows, the demand for efficient, affordable transit options will also grow. I encourage you to use this opportunity to make connections, share information, and shape the future of transit together. Working together, we will embrace new transportation technologies as part of Ontario's plan for growth, renewal, and economic prosperity. As we build our province, it's crucial that we're doing it smart, and you are an absolutely pivotal part of that. Thank you again so much for offering me this opportunity to speak with you, and enjoy yourself today.
Thank you, Minister Cho, for your continued support, your leadership, Minister Mulrooney's leadership, Premier Ford's leadership, and the entire Ontario government. I'd like to now turn it over to Kat Tyrell, Manager of Strategy on the OVIN team. Kat, please.
Great, thanks, Rod. Hi, everyone. Really great to be here with you all today. So I've got the pleasure of serving as your MC for today's event. I'll be walking you through the very exciting agenda that we've pulled together. So we can go to the next slide, and I won't go through it in detail now because we'll get to it. But after this, we've got a quick OVIN update, and then as Associate Minister mentioned, we've got the Ministry of Transportation that's going to be speaking on roadside unit installation experiences. And then we'll take it over to the Hamilton area where the Centre for Integrated Transportation and Mobility will be speaking alongside iSmartways. Then over to Ottawa to learn a little bit more about what's going on at Area X.O in the City of Ottawa. And then back to the Ministry of Transportation to talk about that transit technology toolkit that Minister Cho spoke about. So that's the agenda, that's how it's shaping up. So first off, I would like to invite my colleague, Dan Ruby, who's Sector Manager with the OVIN team. And he's going to be providing a bit of an update. This is the first forum, it's exciting. It's the first one since the rebranding and relaunch of OVIN in December. So we've got a little bit of an expanded scope and some exciting new programs and activities. So over to you, Dan, to provide a few updates from our team.
Thanks very much, Kat, and thanks for the welcoming remarks, everyone. My name's Dan Ruby, and I'm the sector manager for the OVIN team. Essentially, what that means is I'm externally facing. I work with our client companies, the SMEs, and the other enterprises, as well as the ecosystem stakeholders across the province. A little bit of history first. The OVIN program originated as a strategy of the province under the branding AVIN. And it was a recognition that the coming smart mobility revolution, Ontario was very well positioned to leverage in that we had 100+ years of automotive manufacturing and supply jurisdiction. We're the second largest automotive and vehicle assembler in North America. We've got 5 OEMs here in our province and 700 supplier companies, and we're the second largest ICT company in North America. And so this graphic here is more meant to be a visual representation of the overlap between automotive and ICT. And again, being the second largest automotive cluster after Michigan and the second largest ICT cluster after Silicon Valley in North America, the convergence of those two sectors positioned Ontario very strongly to take a leadership position globally in this space. And so AVIN was created to capitalize on that from a provincial perspective. We've now moved into OVIN, the Ontario Vehicle Innovation Network, and we've broadened our scope. OVIN is a key component of Ontario's driving prosperity, and it captures the economic and automotive and mobility technology potential to shape the future of Ontario's sector, as I mentioned. It helps Ontario's transportation and infrastructure network as well to plan and adapt for the future of transportation. We support companies to develop and test and commercialize new automotive and mobility technology, to hire new talent, and to gain access to test and demonstration sites. So to date, we've secured in co-investment over $100 million. Over 1,300 jobs have been created or retained. 300 job placements through our internships and fellowships have been secured. 51 partnerships have been supported at 245 companies. Over 89 million in follow-on investment has been generated, and 25 million in revenue growth catalyzed. The scope of OVIN is public and private transportation of people and goods on public roadways and railways, and it's making that transportation safer, cleaner, and more efficient. And really what we're doing is we're capitalizing on the 4 trends in mobility, referred to as CASE, or sometimes called ACES. So that's connected, autonomous, shared, and electric. Under AVIN, we covered the C, the A, and the S, but under OVIN now we're broadening our scope into electrification. So for connected vehicles, we're looking at V2V and V2X communications technologies, telematics, cybersecurity. On the autonomous vehicle side, we're looking at component systems like perception, driver assistance systems. And on shared mobility, we're kind of looking at ride sharing and car sharing platforms. New under the electrification piece, we're looking at hybrid and battery EVs, hydrogen fuel cells, electric powertrains, critical minerals, and really looking at the entire BEV supply chain. So I work for OCI, and the central hub of OVIN is a team of dedicated staff at OCI that really is the force behind the province-wide programming, the R&D funding, the coordination of activities and resources, and Ontario's push to lead the future of the sector. We're the focal point for the stakeholders, we're the bridge for collaborative partnerships, and really also a concierge for new entrants into Ontario's thriving ecosystem, and we're seeing that growing daily. We drive public education, research, and thought leadership, amongst other things. This map here is really just an example of one of the resources that you can find in ovinhub.ca. It's an ecosystem map of the entire CASE or smart mobility ecosystem. And really at OVIN, what we're acting as the entity that is driving the collaboration amongst the sector, and encouraging the collaboration and tracking and monitoring it and growing the collaboration amongst the entire ecosystem. One of the ways we do that, we fund at a macro level and we fund at a micro level. At a macro level, we fund what we call regional technology development sites. And under AVIN, there were 6 regional technology development sites across the province. And these are all coming back under OVIN and re-upping and expanding their services. And the centers include Windsor and Waterloo, Hamilton, Toronto, Durham, and Ottawa. And these are sites where a company can go and they can incubate, they can accelerate their technologies, they can get business support services. But each of the centers also has a unique lab offering where companies can access specialized equipment and specialized tools. So for example, in Windsor, there's a virtual reality cave. In Durham, there's an indoor all-weather testing climatic wind tunnel. In Ottawa, there's an autonomous vehicle test track. New under OVIN, we're bringing in a 7th site, a northern regional technology development site. And this site's going to be focused on the development of BEV and EV technologies across the value chain, from critical mineral extraction to EV technology manufacturing. This particular site, we launched the call on December 2nd. We received 2 proposals, and the announcement of the site that will be awarded, the winning site, will be very soon, so stay tuned. Another interesting component of OVIN that we didn't have under AVIN is Project Aero. It's managed by the APMA, and it'll be Canada's first zero-emission EV concept vehicle. It's incorporating technologies such as speech analytics and biometric sensors, facial recognition. It'll run at level 3 autonomous technology. It'll have LiDAR, radar, optical sensors, AI, and machine learning software intelligence, and it'll have a complete cyber protection system. Project Aero was initiated in July of last year, and they had over 500 companies registered. 50 companies have been shortlisted to strap on the technology onto this very, very futuristic and high quality vehicle. We're currently in the engineering and build phase, and everything is in progress and on schedule. We're also, something new is we're launching a call for a demonstration zone. This is going to be a site where companies can demonstrate and pilot technologies in live scenarios and conditions using vehicle platforms. So we're very interested to see what's out there and who's going to respond to this call. We'll be launching a call soon, and there'll be a dedicated web page and information on the application form and the evaluation criteria on the OVIN website. The call will go out in May. The deadline for submissions will be in June. We'll be reviewing it in July and looking at making a decision and contracting in August of this year. Another interesting piece that we're working on is a joint study on cross-border mobility solutions with Michigan. We're working with the Michigan Department of Transportation. We've partnered with them on an initiative to deploy smarter and greener technologies at the border. We released an RFP to conduct a joint study on smart mobility safety and operational solutions for cross-border technologies. And IBI Group was selected as a successful vendor for this. And this project will officially kick off next week. Another interesting initiative that we're working on is innovative transportation with 5G. It's a joint SME challenge with Rogers. We're looking to work with Ontario companies on 5G technologies. And we're looking for them to submit on how they would use Rogers' 5G network to leverage precise positioning and low latency that would enhance their transportation mobility solutions. The winning ideas will receive funding to develop their solution at the University of Waterloo, and will be supported by Rogers and its partners, for example, AWS, Hexacon, and others. The challenge will officially launch on April 4th. At a micro level, OVIN also delivers project funding. And so we've got 4 particular programs. Each one is designed to target a specific area of the case sectors. We have an electric vehicle stream. We have a smart mobility stream. We have a winter tech development stream, and the winter tech stream is focused on technologies that are case technologies that are tackling severe winter weather conditions. And we have a talent development stream. Our EV and CAV streams have two streams. So the first stream is stream 1, and these projects can apply for up to $100,000 in funding. These are for 1-year projects. It's a rolling intake on this, so you can apply at any time, and applications will open on April 15th. For our stream 2s in both the EV and CAV streams, these are funding of up to $1 million. These are for 2-year projects, and we have 2 calls per year, one in the spring and one in the fall. The spring call is opening tomorrow, April 1st, and EOI submissions will be due 1st of June. Then we have a winter tech development program. Again, as I mentioned, it is targeting severe winter conditions. It is for 24 months, 500,000, and the dates are the same as the CAV EV streams. Lastly, we have a talent development program where companies in Ontario that are looking to develop these case-related technologies can apply for funding to bring in R&D support to develop these technologies. We have internships for recent graduates of $300,000 for a year of salary support. If the person you're bringing in is a postdoc, a fellow, you can get $35,000 per year over 2 years, so $70,000. Finally, over the last 4 years, we've been very successful, very proud of the companies that we've supported. There's been numerous success stories, and we've delivered 70 CAV and winter tech development projects and 167 talent development projects. I'm right at time, so that's it for me. I know that was really quick, so please feel free to reach out if you have any further questions or interested in getting involved with anything that I referenced above. Back to you, Kat.
Awesome. Thanks, Dan. Definitely lots of exciting things on the go at the OVIN team. So we don't have time for Q&A at this time, unfortunately, but as Dan mentioned, you could reach out to him or any member of the team. So next up, we've got a full presentation from the Ministry of Transportation, their ITS Innovation and Planning Unit, and they're going to be talking about the MTO's roadside unit installation experiences and lessons learned. So I'd like to introduce David Tsui, Senior Project Engineer, and Paul Lim-Hing, Senior Systems Engineer, to kick things off. So I'll hand it over to you and you can share your screen and go through your presentation. And I will mention we've got about 10 minutes at the end of this one for Q&A. So if you have questions, write them down and we'll get to those at the end.
Okay, so just let's look at cracking. So thank you, everyone. So thank you for letting us to share some of the experience that we have in RSU installations and some of the lessons learned. Yeah, so the purpose is very self-explanatory. We're just going to provide a summary of all the different RSU initiatives that we've done in the past, one that we're working on, as well as the one that are in our horizon. So these are the 4 different RSU initiatives that we plan to share with you today. I will be talking about the first 2, and Paul will be talking about the remaining 2. So the first one is the joint venture that MTO did with 470 ETR as well as Metrolinx back in 2017. So this is basically is a V2X demonstrations involving multiple organizations. The objective is very simple. So we just want to gain a better understanding of the basic components of CV data, as well as the way that they are transmitted. The scope is also very straightforward. So we actually, with the supply of 2 RSU units from CAPS, as well as 6 OBUs. The 2 RSUs were located in Pine Valley, 407 interchange, and the other one is Q Street interchange. The 6 OBUs, in which 4 of them were actually installed on GO buses, and the other 2 are installed on 407 maintenance vehicle. So the idea is to have these vehicles equip the OBUs make regular trips throughout this particular corridor. So the pilot applications is just to collect the basic safety messages from the OBUs through the RSU. At the time, we were only able to collect the data at the site, and then we offload the data to remote server for offline analysis. And other applications that we are actually testing is to broadcast preset travel information message that are with geozone specifics, meaning that depending on which directions you're coming from, you'll be getting different preset team messages. Okay, so this is this slide just illustrated how the CV data can be integrated with ITS central system to improve traffic safety. Okay, so what you're seeing here is actually 3 weeks worth of basic safety messages we collect from a few of the OBUs. It's really not that much data, but apparently it took a long time to crank this out because we do not have any automations built in. So everything is basically done by filter and processed manually. So needless to say, if we are going to use CV data and process them on a real-time basis as well as to perform any analysis, we need a very focused big data solutions in place. Okay, so the lessons learned is that we notice other than the OBUs that we deploy, there are actually other connected vehicles out there. So it is a good idea to for any ITS planning that we're going to do in the future, we include CV applications development as well as more CV technology testing to make it part of ITS. Okay, the next one is about our own deployment now. So the previous one that we were not involved in any particular direct contributions. We were mainly on observations with 4.7 and Metrolinx. So this one, we decided to try it on our own. So this particular proof of concept deployment, we started in 2018. It only involved the deployment of a single unit, and we picked 4.1 and Kennedy, the interchange at 4.1 and Kennedy as our pilot site. As you can see, there is the camera pole that we mount the unit on, and the vehicle is equipped with a single OBU. So we have our vendor make regular trips through this particular corridor. And the objective is to basically test the signal coverage distance as well as the location's accuracies. So this is just a schematic a diagram or layout of all the different equipment involved in the pilot test. So what we're looking at here is a capture of all the data that was passing through the unit itself. So based on a 10 millisecond sampling rate and the projected range of about 300 to 400 meters, as you can see, we were able to capture the presence of the OBUs, almost cover the entire interchange of Kennedy and 4.1, including the on and off ramps. And the accuracy is actually good enough to pinpoint the respective streams of traffic as well. What you also notice is that there might be some blind spots behind it, and then we gather this is probably caused by the nearby structures and the static signs, maybe even some vegetation. So that's another piece of lessons learned, is for placement of units needs to be avoided. We need to avoid those geographic conditions. Okay, so in the following year that we decided to expand our project, and we installed 3 more units, 2 on the 4.3 and 1 additional unit on the 4.1, basically in the next interchange beside Kennedy at Midland. So the purpose of that is to test the coverage redundancy between the 2 units placed fairly close together, and also test out some real-time travel time service that we can subscribe and integrate with the RSU and have it broadcast to the OBU that are passing by. We also look at the the data that are being collected is in the storage requirement. Here, there's a couple of things that we learned from the installations. The unit needs to be at least 6 and 8 meters above the traffic, and also to have it mounted flush to the camera pole can actually minimize attenuations and signal loss. So this chart gives you an idea of the size and the type of message that we are looking at respectively. So this is an estimate of the storage requirements, just coming back from 1 hour RSU, collecting mainly basic safety message from all available OBU that are passing by. So yeah, so this is only for estimation purposes. So this is another takeaway or lessons learned is that in addition to all of these different obstructions that we detected that can affect the signal coverage, one other factor is that if we are to place the units about 1 to 1.5 kilometer spacings, it is actually good enough to provide a full coverage in the format of redundancy coverage. So what you're seeing here is a use case utilizing connectivity data for SPAT applications, complete with map data as well as signal-based timing. So this is another illustrations of what type of key message that we can generate in the form of both travel time messages as well as event messages through a cell phone app called Glide. I believe that is the end of my part, and the next part it's going to be conducted by Paul.
Hi, everyone. Okay, so after our 4 RSUs that we deployed in 2018 and 2019, those are very specific applications and locations that were used. So now we wanted to really focus on some, like an entire corridor that we could deploy RSUs. So we identified along the 401. So in the left image, that's our entire fiber optic plant that we have in Central Region at the moment. So we chose a corridor starting from on the 401 from 410 all the way to Highway 418. And that's about an 80-kilometer stretch so that we could, I guess, complement the existing RSUs. And also this particular, I guess, corridor already offered, power, communications, and, a very diverse route opportunities. So we chose 13 locations. Each location has a downstream diversion point. There was, in terms of installation, we chose sites that already had cabinets. Initially, we wanted to, choose sites where poles aren't necessarily there, because one of the criteria was to use infrastructure, existing infrastructure. So here you see our original installation where we're mounting directly to a pole, as David said. Typically, we're just strapping it directly to the camera pole or niche pole. As long as the pole is not too, in terms of diameter, less than 90 millimeter, we found that it doesn't really affect the coverage behind the pole. And here's a initial attempt. We wanted to attach poles directly to a cabinet so that we could easily swing a unistrut pole to mount these RSUs. However, when we did our structural analysis, it was found that in order to support the unit, we actually need a cross section of 4 unistrut posts. So that was way too heavy in order to swing up. So we, after we got the units from CAPS, so we're using the CAPS units, discovered that, they came with these mounting brackets that were more suitable for a gantry overhead, like a pipe of only a 1.5 to 2 inches. So what we finally did was we used a canbrack mass arm, which is more suitable for a traffic signal deployment, strapped it to the camera post and offset the arm with a 1 meter aluminum arm, and then mounted the RSU onto that, I guess, arm. In this particular case, we were actually, I guess, moving away from the direct perpendicular, shooting across the highway. And in this case, we're pointing directly to the oncoming traffic. So it's another way we're testing whether or not, this would be a better in terms of coverage. And obviously pulling down the cables from the RSUs to the cabinet, we've installed easy routers, which facilitate, cable entry into the cabinets. Here's a little demonstration whereby, having infrastructure behind your RSUs, especially additional poles, will affect your RF coverage behind the poles, behind RSU. So it's very important to determine, what's your aim, what's your targeted traffic corridor. And as long as you have that coverage, then you're okay. Or if you should actually add additional RSUs if you want. So after installing all these RSUs, we decided that, hey, we need a back-end tool to monitor and control all of these RSUs. So we're piloting the CAPS CMCC platform. So we've now securely, I guess, given access to the RSUs via our internet to these units. And with the CMCC, we're also going to be testing different use cases like work zone, congestion. So we're looking at not just getting BSMs, and pushing TIMs to the RSUs to disseminate, but actually getting events from these RSUs for situational awareness. But ultimately, I guess we want to somehow integrate the CMCC and use it as a almost like a translator for us, integrate it with our Compass on CTMS applications, which is our current central traffic applications. And by using the CMCC, we'll be able to push any events that we normally would, send to our VMSs, and now send them to the RSUs and actually create these like virtual RSUs. And obviously, SCMS is part of the mix, and we are in like piloting with BlackBerry their Certicom SCMS. So we've enrolled, I guess, on the first 4, we did enroll those, and we did test a few use cases with them. But obviously, with these additional 13s, we'll continue with that. Lessons learned, I guess, the first thing is always, pre-configure as much as possible all your devices so that you can easily hand it over to the installer, and they can, quickly move from one site to the next. Obviously, determining ahead of time which way to face the antennas, making sure you have sufficient room behind the barriers to park your bucket trucks. If not, is there, enough shoulder clearances so that their outriggers don't impede traffic or safety issues. And also grounding the RSU. So that, a lot of people don't really, they pull a PoE cable, connect it in, and that's it. But you really need to follow the RSU 4.1 installation guidelines from USDOT. So I guess now we're in 2022, and our next step is, well, we're moving to another corridor. So we have the 4.1. The 4.1 is our like little sandbox to play around with. But this corridor that we've identified is along the QW from Burlington to Toronto. It's a unique corridor in terms of it already has all the infrastructure that's needed. But it does have, like ramp metering, HOV, the upcoming LRT, parallel transit corridors, municipalities that passes through so that we could do some regional collaboration, high winds from the Skyway. So it's an ideal, I guess, corridor in order for us, for other participants now, not just us, to participate and I guess demonstrate their technology so that we could, get better in tune with what's out there and help the economy of Ontario grow. So with the innovation corridor, we're currently assessing all the digital and physical infrastructure to see what we have available to attract, participants. So it could be the fiber, it could be the power, could even be the back end office, for storage. And then we're developing a framework to figure out, well, what's the best way of operating and managing this corridor? So I know, there's different scenarios that we've been looking at, but ultimately it's how do you attract these participants? So it's either going to be we've looked at challenge bases or like OVIN, previous speaker, was talking about open calls, right? Okay, so that's it.
Great, thank you so
Any
much.
questions? Okay.
Yeah, so we've got about 5 minutes for some questions, so I can open it up to the floor and feel free to jump in if you've got any, or you can write your question in the chat box as well and I can read out some questions. So one question came in here that I can jump in with 1 second. Which vehicles were the OBUs installed in and what information from the vehicle OEM was required for these trials?
Yeah, Dave, I'll take that one. So all the OBUs were either installed in our own vehicles. So there's no OEMs that participated in any of these, I guess, use cases. Right. The ones that David was mentioning when we did our deployment in 2018, we did pick up these phantom OBUs. So they're not recognizable really, other than, you get the BSM, but there's no identification associated. Now, moving forward, when we're doing the 401, we did purchase additional OBUs. And I guess I didn't allude, we are doing the CV2X, I guess, deployment as opposed to DSRC. So the first 4 were DSRCs. So now we're focusing strictly on the, LTE 5G components now. Those we're going to try and push out to our fleet, well, maintenance vehicles, hopefully, so that when they're, driving around, they can help us with the use cases. But, as everyone knows, the penetration right now is fairly low. So in order to, get that penetration, you either have to do it yourself or try to get other partners to participate.
Yeah, that's going to be an ongoing challenge, the way we look at it.
Yeah.
Lack of OBUs, yeah.
All right, so I think we'll take 2 more questions. I see 2 hands up. So maybe I'll go to Sabir first. Sabir Syed.
Yeah, thank you. So I'm Sabir Syed, Manager Transportation System Planning, Region of Peel, and Paul and David, excellent presentation. So I've got 2 questions. The first question, how can the municipalities like Region of Peel can participate and collaborate with you? And the second thing, that Region of Peel has established a Smart Fare Center with University of Toronto, McMaster, York, and Ryerson University, and Smart Fare Center is working. So we would like to work on the goods movement side as well with you. So those are the 2 questions.
Yeah. So I think, on the MTO side, we're very focused on, high speed traffic, whereas on the municipality side, you're on the lower speed. But I think, especially, for traffic signal, RSUs are very well established in that area. But as from the provincial perspective, I think for terminal ramps, we're thinking of using the RSUs to help us with that. But I think in terms of the collaboration, I think we should be able to exchange, even share RSU information, not just keep information to ourselves, but allow other, almost like you're using it for 2 different parties with 1 device, so that we could pull data off of each other and share it amongst ourselves. They always talk about once there's an event on a highway, the municipalities should also be informed. And I guess with this connectivity, it's going to be a lot easier. It's just, as it's just getting to that, mutual agreement and how and what we want to share.
Yeah, I think one of the key issues that the previous pilot that I mentioned with 47 and Metrolinx, we're also in consultations with York Regions. I believe they were planning on installing some of the units on Jane Street at all the major interchange around Vaughan area, right? So, yeah, I think it's a matter of focusing on all these, looking at all these different CP technologies and figure a way on how to work interoperability. Yeah. So that is one of the challenges that we need to face.
Thank you.
Okay.
Okay, so one more question over to Mike Parks, and then I think we'll have to wrap up this session and go to the next speaker. Over to you, Mike.
Thank you, Kat. And Paul and David, great presentation. Thank you for sharing this information. I'm Mike Parks. I'm with the City of Brampton. So I support Sabir in how can Peel/Brampton get involved? Because I think this is a great initiative. But I did have one question specific to your new corridor, the Burlington QEW corridor, as I recall from your presentation. And that you mentioned that something about, and I can't remember exact verbiage, something about opening it up for others to pilot. And that's the piece I'm curious about. What exactly does that mean?
Yeah, so I mean, it's similar to a lot of these other test beds or centers where you have the facility to invite, or people would volunteer their equipment to test. Could be CV application or any type of safety application. The uniqueness about our innovation corridor is that it is, a live test bed area, as opposed to some of these other ones that are closed. So we're not thinking, you have to have some type of maturity in your product, right? So when we talk about, who gets to be involved in the corridor, we're looking at, do you put out an open call? Let's say you put out an open call because I want to do safety zone, applications. And then participants would, submit their proposals, and then you vet them and you evaluate them, and then you say, okay, these are the ones that we're going to choose to, participate. But in order to participate, obviously, a lot of the infrastructure has to be there ahead of time, and it depends on what they need. So I think we've identified a few key infrastructure, calm, power, to be the main ones, and also maybe back end services, so that when a provider comes, he doesn't have to worry about maybe RSU. He doesn't care about an RSU, but we can provide an RSU, and then he loads his application on the RSU and he tests. He doesn't care about access to the bringing his own comm. We provide that to them, right? And I think someone mentioned earlier, 5G. I mean, there's a lot of interest of putting 5G down onto the corridor, but again, it's very not restrictive, but with the millimeter wave, like the really fast stuff, when we're talking about safety, latency is a key. So in order to do that, they have to put up a lot of antennas along the highway, which isn't happening very soon. So it's a way of attracting vendors, to our corridor, to support our economy, and also, as I said, to get MTO prepared for CV.
All right, thanks very much. That was a really great presentation, a lot of really great lessons learned and insights shared. So thank you for that. I think in the interest of time, we're a little bit behind schedule. If we can pull any other questions or comments into the chat, we can have some back and forth going there. I think we'll move on to the next set of speakers. So up next, we're moving over to the region in Hamilton. So we've got Richard Dunda, the director of the Center for Integrated Transportation and Mobility, along with Charlie Cheng, the head of business development at iSmartways, and they're going to be speaking to you about preparing for V2X in municipal infrastructure and operations. So over to you guys to share your screen and go through your presentation. And again, we'll have some Q&A at the end for this one.
Good. Thank you. Richard's going to go first, so I will move to the next slide. Thank you. Pleasure to meet everybody.
So go ahead, Charlie, flip the slide. I'll just say a little bit about CITM. CITM is one of the OVIN regional technology development sites. Can you advance slides, please, Charlie? We have one of the things we keep going. One of the things we offer is 4G, 5G connectivity, as well as V2X technology on a test site that's located on a private road at McMaster Innovation Park. So our job as an RTDS is to help companies developing startups and scale-ups that are developing technology for connected and smart transportation, right? Test and develop their equipment, thus the test site. And we are just in partnership with McMaster also adding an advanced traffic management system So we'll have the ability to integrate traffic management signals as well as vehicle infrastructure and infrastructure to vehicle communications on that test site. The rest of the slides I'll leave for your reference. Happy to take any questions later about CITM and hand it over to Charlie. Just a note on that, I see Susan making the note on the innovation corridor. That corridor ends just at the truck before the bridge, which is Hamilton, as you know, has a lot of truck ingress and egress out of both the bridge side of Hamilton Bay as well as the city side. And truck route and truck management is a big issue in the city of Hamilton. It's also a port and an airport city, so we deal with multimodal transportation. Okay, Charlie, over to you for the V2X stuff. Let's keep going.
Hi, can you hear me? I hope we can hear me.
Yes, we
Okay,
can.
cool. Thank you. Sorry. Pleasure to meet you. So I am a business development manager here at iSmartWays. We are a Canadian company founded in 2014. But I'll talk a little bit about the company later. I kind of want to preface a little bit, but obviously a lot of the people on the call know what V2X is. But I figured if there's any on the call that aren't familiar, what we call it, and we see this a lot in Europe and Asia, is cooperative intelligent transportation systems. And I won't go too much into this slide, but the focus I like about this slide is the word cooperative. And really, for all the systems to work together, we found that there needs to be collaboration, not only in terms of the technology, but also in terms of from the business perspective. One thing I did want to mention is the power of the CV2X technology. And this will kind of be a little bit of our talk. The talk today is kind of going from a 50-foot high level of the wireless space, let's say, above us, and how you can maybe rethink transportation going forward. But for the power of the CV2X, obviously it starts with 3GPP release 14, PC5 mode 4. And this allows for both vehicle communication to infrastructure, to pedestrians, to bicycles, to network, anything in the future, hence the X, both in terms of direct and network communication. So both utilizing that Wi-Fi IEEE, DSRC, 802.11p, PC5 side link, as well as also the licensed cellular spectrum. And we think that's a big benefit, especially when you get into safety critical cases, as well as non-safety critical cases. A little bit about iSmartWays. We are an IoT transportation solutions provider. We specialize in cloud-based solutions, edge computing, connected vehicles on board, and intelligent roadsides. As I mentioned, we were founded in 2014, and we have roughly about 2 decades of research in this specific area. You can see our products or our product portfolio. We like to promote a 3-tiered structure to a transportation network, including the cloud on the top layer, the edge, whether it be the multi-axis edge compute, or what we've done with CITM and the smart mobility network using the smart cone as the edge, which I think is a very interesting proof. And then on the lower layer is the IoT or the Internet of Things. And obviously in there you have your onboard units, your roadside units, as well as your ITS stack, whether it be an HMI, the applications developed either on an Android or a more traditional display device. And then also on the roadside and in the car, you have both sensors, LiDAR, radar, camera, etc. And so all of that data then will be going from that bottom layer, and whether how it's processed in the edge or the cloud is depending now on that smart mobility network. And you can see some of our company locations on the right. And before I get into a little bit more about V2X, I figured I'd start with automotive, because a lot of traffic and transportation is, starts with automotive, just like, you had the vehicle first, and then you had the cement roads, and then you have the traffic signal controllers, right? But I like to play this because it focuses on the rethinking of the transportation. And 1 second, I'm going to go.
We're talking all things
Can you hear it?
automotive. Traditional automakers are dead serious about making electric cars. Now that is. But they didn't start out that way. And even when they started to take EVs seriously, they made a major strategic mistake. Now, they're all scrambling to correct that mistake. But can they pull it off? More on that in a minute. First, some background. This story actually starts about a decade ago, when traditional automakers needed to generate EV credits to meet emission standards. If they sold a few electrics here and there, They could get enough credits to avoid stiff fines, especially in California. But none of them believed that their customers were interested in electric cars, so they made what were called compliance cars. Electric cars that were only designed to comply with emissions regulations. We're talking about cars like the Fiat 500e, the Volkswagen Golf EV, and the Ford Focus EV. The car companies never really put their heart into it. They just took an existing car, gutted the powertrain, stuffed it full of batteries, and called it a day. But it was about this time that the Tesla Model S hit the streets and caused a sensation around the world. Tesla proved that if you designed a great-looking car with terrific performance and bleeding-edge technology, there would be a long line of customers who were eager to buy an electric.
And so I won't play the full video because we won't have some time, but I really recommend it for people who are familiar with the Detroit auto community. John McElroy is pretty famous. He's on the radio all the time giving updates on the automotive. And he goes on and talks about how the traditional automakers assumed that they could make these electric or what he calls compliance vehicles with the existing pins and pistons of their existing assembly lines. And as you see now, fast forward, right, to now, you see a lot of those automakers making that same change of now creating new factories and new lines specific for electric vehicles. And so I use this as kind of an analogy for
their compliance cars.
For the infrastructure. And the whole idea is that same kind of disruption that happened in the electrification. And also, if you think about it, when of the charging infrastructure, that similar disruption happened in V2X, and especially in the US. And that's what I mean when a little bit of the topic today that I'll be giving is the rethinking of the transportation. And so this was taken from a US DOT, and I really like it put together because it shows you the impact of what the FCC did in terms of reallocating the spectrum. And obviously the spectrum, the 5.9 was allocated in 1999 and given specifically for ITS, right? And as you see in November 2020, they've decided to reallocate it, shrunk all of it into the upper layer megahertz. And you see now there's a question and there's still testing going on of how that impacts the radio frequencies, as we discussed before. But I also show on this next slide a kind of a worldwide view to show you that how the space is currently developing also in other countries. But obviously this is more the Western view. So you think of European, Canada is on the UK, Australia as well. But you see now what has happened in the US with the reallocation, and they've kind of shrunk it down. And also they paved a way, let's say, for CV2X. And then here's from the Asia perspective. Now, Japan is very interesting, right? A very different frequency. So if you think from a vendor perspective, you know, there's definitely different aspects from a technology that we have to work. But generally speaking, Asia, and now you see the exact similarity between China and the US in terms of the spectrum used. But also it shows you a little bit of how involved each country is in this technology. And as you see from the US perspective, right, these are all the states, and this is fairly new, March 26, 2021, of the pending applications for the use of the safety band, right? And there's a widespread deployment, whether it be as part of their Smart Bat Challenge and et cetera. But the focus of this was really that, you know, that same disruption has happened because the industry and government perhaps have realized that they needed to rethink how transportation is done, right? And a lot of the focus that we see should also, from a municipality perspective, on making sure that connectivity in the airspace is effective enough, low latency, high bandwidth, et cetera, to actually do the things that we talk about in terms of the applications. And so I'll show you right here some of what we think are day one use cases, that things are happening out of the box, that, like I mentioned before, the cooperativity aspect, the connectivity, the integration, the interoperability are all things that are very challenging. But definitely from a first, day one use case, the idea of digitizing the roadway, right? And something as simple as the geometry aspects can also be quite complex, but this is something that's fairly easily necessary and easily done in the first day one of the use cases. And obviously the standards matter a lot in this aspect. We also see a lot of discussion around transit signal priority, right? And we think more, and less of the, not so much of the smartness aspect of it, but just from the connectivity aspect of it. Can you communicate the traffic signal in a manner that makes drivers more aware and also provides the information to the traffic side. Another use case that we see is some of the work zone warnings, right? When the earlier presentations talked about TIM messages, right, and being able to then segment a particular road or the direction of the roads, and so creating virtual work cases are also things that we see coming around fairly soon. And lastly, also the smart highways. We see a significant increase in traffic efficiency, right? Especially decrease the time to destination. What was talked before about on-ramps and off-ramps. We also see the applications in terms of tunnels, right? Where GPS signals may not be as effective or present. There's also increases in fuel savings as well as real-time traffic updates. But the biggest emphasis on these day one use cases is obviously the non-line of sight awareness. But you kind of have to make steps towards that full connectivity level and seeing around the corner. And so a basic level benefit we see is just from the warnings and the alerts, just notifying things that are there, right? That connectivity aspect, not getting into control or device management or active control of the signal, for example, but at least showing what is the status of, and then thinking about static signs and dynamic signs as well, right? But all of this does require configuration optimization. And so we've been in this for a long time, and we do have deployments both in North America and in Asia. We've been also looking at Europe, but we've kind of put together a kind of a deployment steps in terms of applications. And we start on the left with what we call technology demonstrations. These are the basic, applications packages. These focus more on demonstrations. You talk about BSMs, MAT, SPAT, TIMs, or RTCMs. And then we move from there, and we think that takes a period of time of configuration and integration. And that's when you get into a lot of the standard applications, the core ones, when you talk about SAEJ 2945 or the newer one, SAEJ 3161, talking about forward collision, intersection moving, more of the V2V. And then we think really in that last stage where we think where a lot of the deployments are now is that that full mass scale adoption. And so and that's where we see more of the last slides. And I know I'm running out of time, so I'll finish up really quickly with one last slide. And so the top 10 considerations. Road operators should be focusing on connecting a real-time connectivity and obviously correcting the wireless space, as I mentioned above, for device-to-device communication. A big thing that we see, as I mentioned on those deployment steps, is the interpretation of the industry standards versus the interoperability of the actual devices, right? And that actually requires both industry research and standards to work on that, because inherently the technology has optional features. And so I won't go into each specific one, but the topic was really about rethinking transportation.
All right, thank you so much for that. That was a great presentation. I can open it up now for questions. So feel free to raise your hand or type a question in the chat and we'll go over to you. I might kick off with one actually. Which use cases or implementations do you expect to see first with V2X deployments?
I go back, yeah. So this is a question that we get a lot as well. And I think the whole industry is focused on this topic because a lot of the people also assume that the things can work out of the box. And that's where I like talking about that space of segmenting it in between vehicles and infrastructure. So from a vehicle application, right, obviously the ideas is the basic safety messages, right, positioning in itself. But then on the infrastructure perspective, obviously we think the signal controller is the best first day one use case, but that's quite tricky is what we're learning and very fragmented from an industry perspective. And so we really think that the standard applications mentioned, right, the SAEJ 2945 are really the ones that should be initially tested. And then really more of the V2I applications are the ones that require a lot more configuration and integration work.
Okay, thank you. Any other questions from anyone around the forum?
Kat, just a comment. Well, one of the points that Charlie made was that, essentially both communication standards, DSRC or direct, right, typically Wi-Fi and cellular, are viable methods of communication. So what that means, and that's great for the infrastructure side because it's easier to put Wi-Fi at intersections if you're doing urban traffic management and control. Cellular better for highways. But what it means on the vehicle side is they have to have 2 radios in the vehicle, which increases the cost to the automotive or vehicle manufacturer. So it's still to be seen what that means, but it may mean that some of the use cases are much more narrow in terms of what gets done first because of the limitations on the vehicle side. So it'll be interesting to see how this rolls out. It may be that sidewalk delivery robots, right, in urban settings are much more likely to see this technology deployed because they need to be managed, as opposed to mass transit or vehicle standard automotive vehicles running around on highways with V2X in them. I don't know, we'll see.
Yeah, no, that's a great point. Kind of where will it land first, and then like what will it take for it to get to like citywide or region wide? But step by step, I think. Sorry, go ahead.
Highways are clear. You need cellular because of the distances involved. Wi-Fi doesn't work. Right? That's great for trucks, but cars might not have those radios in them. So we'll see.
And that's kind of I bank off of that point, and that's kind of really again the focus was that, you know, with CV2X and that specific one, and obviously on the future when you go to 5G, which we also do some testing and piloting in China with 5G devices. So the newer chipsets, we do have some prototypes and stuff, but we see that, right, the power of the CV2X and the 3GPP is that it does have that network and for a licensed spectrum and the direct communication. And so when it comes into then specific applications, the applications are very broad, as you see from the slide. The list that we see in the US are now topping over 100 different kinds of applications, and they also involve electrification, right, vehicle to grid, but that's really up to the end users. And in that space, you know, as we discussed, it's not really clear yet, this business model of where each industry or segment plays a role. And so that's why I think that a big focus should be on ensuring that from a municipality or from an infrastructure that network connectivity is present, it's capable, and it's also efficient. Because without that, if you think about a smart home, if you just think about connecting your devices at a smart home, connecting your lights, that internet connectivity is very crucial to everything, right? And that same ideology, I think, should be adopted on the municipalities and the infrastructure side, because the applications will land as they land. It depends on the end user, right? And so unless the city plans on being the end user in this condition and actually operating the applications to the driver. Now the infrastructure applications are a whole different, right? HD mapping, etc. But at least from the vehicle's perspective, that's kind of left up to the operators and the drivers. And so,
Kat, there's a good question in the chat. Said, any thoughts on the liability with respect to jurisdiction providing information to vehicles? I'd add, or vice versa. The answer to that is that's a quagmire. Right? Like, what does it mean to send a piece of information to a vehicle that says there's an accident around the corner, expect a traffic tie-up? What does it mean to do that in a legal context? Right? And which vehicle information is acceptable to send to the network before you hit privacy? If a vehicle's speeding, is that private information? Are you subject to privacy laws? Right, or is that safety information and privacy laws get overridden? Right, some of those, so all of those use cases and limitations on data use still need to be worked out from a legal perspective. The technology is arguably easier, right, than legal and regulatory.
And I would add, you know, if you think about applications right on your smartphone or things like that, it's essentially what they've done. It doesn't work out as simple as the smartphone because you're interacting with different systems, right? But if you think about safety from a vehicle's perspective, you know, one way is they're mandated. If you think about Euro NCAP or NCAP, right, is that they have to have this, and it's pretty clear that that is the direction that V2X will be included, or sensors perception in general from the vehicle's perspective. So now the question is on the infrastructure side. Let's say you had an application on the infrastructure side and you wanted to charge for it. How would that look? And that's also another thing that we really didn't get into. But the part of the rethinking transportation is then you could then begin resegmenting lanes and the whole traffic network. And so instead of maybe, let's say, the left lane being the quick lane and the right lane being a slower lane, for example, you could have more of the multimodal transit on the right, right? Or redefine how the lanes are used, redefine how the traffic equipment is used. But all of that starts with first the network connectivity. But definitely on the infrastructure side, it's very curious to see how things will go, because previously it's been kind of single shot. You put a camera up to do detection or monitoring, right? Or maybe even futuristic of the automated ticketing, right? But never you think of a widespread, what is my platform in terms of a city look like in terms of infrastructure? And so that's now where I think a lot of the cities could begin thinking of managing the transportation network. But how that works out is something that requires piloting, testing, and deployment.
Yeah, and just one last point on that. Because of the issues of data, privacy and security, it may be that the use cases that get done first are on private roads, right? So as an example, CITM works with ArcelorMittal Dofasco. They have a massive vehicle that transports steel coils around the steelmaking yard. It's so big that that vehicle requires spotters, right? So it doesn't run into someone because the driver can't see the front and the back of the vehicle simultaneously, even with cameras, right? So that's a natural use case for V2X. It would increase public safety. At some point, that vehicle needs to transverse a public road. That's a great use case for V2X, right? It increases safety, it lowers labor costs, right? But it's a constrained use case in a private environment.
And I add one more thing. I'll show you one more slide. This is some of the stuff we do in China. I figured that it might show you some of the stuff. This one, actually, I'll show you both. So this one is in Suzhou, and this is also going to be the host of ITS World Congress in 2023. So we welcome you guys, anybody on the call, to come and see. We're definitely going to be doing demonstrations, a lot of AI and autonomous vehicle testing. But you see, we've done a more wide scope of integrating all the ITS infrastructure, and also we've done a lot of the millimeter wave testing and piloting. But one thing that, as I alluded to earlier as well, the electrification, right? Because now cities naturally have to begin thinking about electric charging infrastructure, and you naturally will want those connected. And so just have those power for that alone should then also be able to be used in some way or leveraged with then intelligence or connectivity from these devices, from V2X. Right, and so that's some of the stuff that we're also seeing in China, but more particularly, for example, this is in Wuhan, which if you guys with COVID before, you probably never heard of it, but now you've heard of it. And this is some of the stuff of the automotive vehicle testing side, but we do also deploy a lot of the edge, and that's where we also see it from the data processing and that connectivity perspective plays an important role. So I just kind of end with that.
Great, wonderful. Thank you very much, both of you, for joining and presenting today. A lot of great insights, again, shared out of this presentation. So thank you for that. Any other questions, put them in the chat, because I think we're going to have to move on due to time. So the next presentation, we're moving over to the Ottawa region. So I'm going to introduce Kelly Days, who's Director of Strategic Marketing at AreaX.O, and Omar Chowdhury, Project Lead of Transportation System Management at the City of Ottawa. And their presentation is on enabling the safe adoption of V2X smart mobility innovations. And again, we'll have the Q&A at the end of this one as well. So I'll pass it over, I think, to Kelly to share your screen.
Okay, so hey everybody, I think we've presented before, so I have a few slides just laying some of the groundwork for what we do at AreaX.O, but I'll go through those very quickly in order to stay on time. So I'm Kelly Days with AreaX.O. I've been involved with OVIN and OVIN since day one, so I'm excited to share the work that we've been doing. I'd also like to introduce my colleague, Mr. Omar Chowdhury, who comes from the traffic group at City of Ottawa. I know today the goal is to share some of the work that we're doing in partnership around V2X. So since day one, the City of Ottawa has been a really core partner of the work we're doing at AreaX.O. As the Regional Economic Development Agency, we've always worked hand in hand with City of Ottawa. The Mayor's co-chair of Invest Ottawa, which operates AreaX.O. But I really have found over the last 4 or 5 years of the OVIN project, the relationship and the opportunity to collaborate at a city level has has in my experience moved to a whole new level. So I'm ever so grateful to the City of Ottawa and excited to tell you about some of the work we're doing and to share some of the best practices and frameworks, and was really excited to see the MTO work in an actual presentation. We're quite aware of it. We've been building on that with some of the same partners, and also great to see iSmartWays. We're doing some work with them as well. So again, our whole framework for adoption of these new innovations that we've developed with City and our industry partners, it's really around testing first in a private scenario and then safely moving into real world adoptions. And this isn't easy. I know we have some municipalities on, and Omar will share some of our particular experiences at City of Ottawa, but for us, this really started at City Council and anointing some smart city councillors that would really help support some of these initiatives, finding the champions internally, but always moving forward in a very safe, controlled fashion. That's the number one thing. No risk. I heard the word liability in the last presentation. These are thoughts for municipalities, and safety is everything. So having the private test facility that we do in Ottawa, which is absolutely open to other municipalities to use, it's part of the OVIN proposal and project, I think it's a really critical piece of the work that we do. 100% we're driven by industry, which I think is exciting. It allows us to take that knowledge and expertise as part of the work we do. These are hands-on expertise. So when we work with BlackBerry QNX, it's the engineers there that work directly with us, or Nokia or Ericsson. So from an SME perspective, we all know why we do this work as part of OVIN. It's to really accelerate the work that's happening in Ontario with our small and medium-sized companies in particular, providing them these multinational expertise and infrastructure and assets to be able to demonstrate and validate their work is 100% why we're doing all of the things that we're doing. Quickly, we have 2 test tracks. So there's a private test track, completely fenced and gated. It's a federal government research facility. It's been fit up in partnership with Day One for the City of Ottawa, installing a 4-way traffic intersection, a 3-way traffic intersection. They painted all of the roads, repaired the roads, pedestrian crosswalks, 1-way street with a 2-way bike lane. Everything was done by the City of Ottawa to ensure it was as close to real world as possible. The whole idea, again, that we test first at private and then move to public. We also have an at-grade level rail crossing, which is fantastic. And then, of course, all of that infrastructure is fiber backhauled to our command center. So we have complete control, enabling all kinds of different use cases. We also have a public test track. It hasn't had as much play over the years, but we really did launch the public test track in 2017 with BlackBerry QNX. We deployed, I think, 10 DSRC units, CODI units, on real world infrastructure at intersections, sending out stat and map data. And then the QNX vehicle was able to receive that information and use it as part of its processing and decision making in autonomous mode. So we have a lot of history in this RSU V2I work. And so I'm going to talk a bit today on some of the sharings that we could share with this group and the new projects we have. Again, just the communication infrastructure at our private test track is really, really critical to this work, really critical to the work we're going to talk about today that we're doing with Transport Canada. But we run LoRa, satellite backhauls coming from Telsat was a missing piece of our puzzle, 5G from Ericsson and Nokia, including millimeter wave and C-band coming at 3.8 gigahertz from Ericsson, which is aligning to the US rollouts. We have the end devices for this. We run band 14, 3 different GPS systems, TV white space. So when companies come to the private test track, we run our own complete private network. So you can do unimaginable things on our network, whether it's looking at, cybersecurity, takedowns or hacks or other kinds of things or bandwidth issues. Because we run our own network, all of these are able to be done at our site. We have a lot of assets available for cars, and a lot of these assets are being used in the projects we're going to talk about today. We have our own autonomous car. This was fit up by Autonomous Stuff, which is Hexagon. They're co-located at our private test track. For some of the new projects we're doing, we've just added a 40 gig antenna to it. We've integrated an onboard unit. So in autonomous mode, this vehicle is able to receive safety messages, able to act on safety messages, but it's also an R&D vehicle. So you'll see the weird you know, on top of the vehicle and the bumpers. You can install all kinds of different sensors to the vehicle, collect all that data in the trunk. There's huge storage and compute, and you can also take the real world data from the car. So I think as we move through this work, some of the next steps on the MTO project, this vehicle is a game changer, and we're excited to share it with others and some of the work they're doing. We also have our own shuttles. We do a lot of drone work. So I know that it was mentioned on robotics, on sidewalks, but the cellular drone area is really exploding. And we do a lot of work with cellular drones at our site. We also have the test mannequins, which we're using in a lot of our projects. So you'll see in the bottom right, they're very complex. We are experts at using them. So we have a child, an adult, a cyclist. We're looking at getting a thermal child as well, which is really important on the machine vision use cases and Four Seasons. And again, just all these are available for companies to use. We have all kinds of sensors, eval boards, etc. So I'm going to turn it over now to Omar from the city to talk a little bit about some of the work that we've taken, I guess, about 3-4 years to really refine, and we are now launching in partnership with City of Ottawa. So Omar, over to you.
Thanks, Kelly. Yeah, so I mean, for the City of Ottawa, you know, and certainly from our traffic services perspective, it's been really important for us to be able to work with Area X.0 and be able to leverage the capabilities and capacity that they have there. As Kelly said, you know, the city has invested funds through installation of the four-way traffic signal that's actually connected to our traffic operations center, so we can actually control the signal itself. We have staff now that regularly go out there to help support the installation of equipment at the different intersections. And so what, you know, for a lot of the SMEs, small businesses and companies looking to sort of build and further test their technologies, one of the really important parts is the process that we've sort of set up with Kelly and the Area X.0 team. So they really become the intake. They work with a lot of different companies and be able to use that as an opportunity where they will then go through and sort of do that preliminary review. I know David and Paul, you know, when they were talking about their project, it's like, how do we decide which companies can be involved and are they ready to be involved in the real world? And that really is that, you know, review of product readiness sort of step that's there in the second box. And Kelly and the team will go through and see whether or not the product is, you know, an idea on a napkin, so to speak, or whether it's a sort of an early prototype where it's actually almost ready for commercial use, and go through that process. And if they aren't, they'll go through the process of being able to test locally at the private test track. And once the team is ready, and I'm out there regularly as well, so I'm meeting with different teams and learning what they're doing, and that provides us a really good perspective on what is coming, what's the new technologies, what people are trying, so that we can be prepared as these technologies start to come out. And then we will then go through and do a technical review and verification. So we may require that a company demonstrate that the technology works. We will work with them to say, you know, like it's 300 feet from one, you know, where they can grab power to the opposite corner of the intersection if they go around some of our larger intersections. Sometimes they don't actually, they aren't prepared for that. They haven't thought of that sort of process. So as we're working through, we work with them to be able to identify how they can actually properly deploy, because it's one thing to run a pilot where you make up some sort of, you know, you jerry-rig or MacGyver, some sort of power connection or communication connection. But it's another thing for us. We have 1,200 traffic signals across the city, and so how can we actually process and work that through? So once both our traffic signals folks as well as our operational folks and safety folks are comfortable with the technology and we can roll it out, then we'll execute an agreement and then be able to deploy it for a period of up at least 60 days. We go out there every other month and install at the smart intersection. So Kelly, if you can maybe move to the next slide. And so here's, Kelly was talking about the public test track. And so this is one of our major intersections on that public test track. Over the last I guess almost a year now, we've been looking at and have deployed some of the technology around there. Some of the technology has now come off and other new technologies are being installed. But over on the left, at the left-hand side is where we, the city, have our own cabinet and power. What we've done is we've actually created a dedicated cabinet and power connection over on the right-hand side. You can see that gateway cabinet box and a dedicated pole that companies can put their equipment on. That's generally our preferred location, but we understand that some companies need to be a little bit closer to the intersection. And this will, again, allows them to look at what is a very heavily used intersection and be able to test their technologies to be able to then be prepared to move the next step. Next slide, Kelly. And so, some of you probably heard of the project that we had run, I guess it would have been about a year and a half ago, I guess now, out at Tunney's Pasture, which is one of those low-speed automated shuttles. And the value that we actually had working with Area X.0 is that we could actually run through a full test project there with the test dummies or the mannequins to be able to verify that the technology works. We were working with Transport Canada to run through a series of test scenarios, and it was a very long 12-hour day, 5 or 6 days of testing with staff to be able to go through and verify that the technology worked to our satisfaction, to everybody's satisfaction, before we decided to take that shuttle and then deploy it on this test track here. So I think, Kelly, that's sort of my step, and I'll turn it back over to you.
Yeah, thanks, Zora. Yeah, the shuttle project was really the first opportunity, I guess, except for the deployment in 2017, where we got to check this framework, which is test in private, then roll out into public when everyone's ready. I also want to just highlight that, of course, anything that involves city infrastructure or real world deployment, 100% go, no go, it lands with the city of Ottawa at any time. The city can stop or decide not to deploy. So I think that's a really important differentiation as we kind of learn towards lessons learned. So one of the projects I want to highlight today is the Transport Canada project that we're currently, that's currently underway at Area X.0. It involves about 8 Ontario-based small, medium-sized companies. Many are from the Toronto region, including companies like Fortran Traffic. We built on the work that was happening with MTO, so we utilizing the Catch RSUs and our partner BlackBerry, their SCMS. And we're also using some of our assets and infrastructure, and we're enabling a use case. So I think there's a lot of talk about what can we do with this sorts of technology. So the use cases are really around vulnerable road users. Another thing I'd mention, really important to us, especially with the work we do with Transport Canada, is building on regulation and policy. So we're applying the World Economic Forum's AAM Safe Driving Scenario-Based CAV testing framework to all the testing that we're doing at Area X.0. Maybe just go to the next slide here. Let's see, there we go. Yep.
Just before you go, there's a bit of a black box that I think everybody's seeing. Is that showing up on your end?
Is it this? Does it move now? It's like a toolbar that I have that's coming from here. Let me just see if I can close it. It's like a, it's a toolbar.
Moved. The toolbar moved. Oh, now it got worse.
It got bigger.
Oh, that's a, leave it there, Kelly, maybe.
How do I close it? Does anyone know? Anyway, it's a toolbar that's on the Zoom app.
Interesting. Okay. Well, if it's in the corner, I think it's not as obstructive. It's a bit better where it is now.
I'm really sorry. I'm afraid that I punt myself out altogether, which would be probably what would happen to me. Again, we'll share these slides after. But a lot of the work that we're doing like I said, our framework is test first at the private test facility, then roll out into the public intersection that Omar was highlighting. So a lot of the work that we're doing, it's sending safety messages from the machine vision sensors, the different companies' technology to our autonomous Lexus. So we have an autonomous Lexus fit up by autonomous stuff. As I've said, it's currently getting an integrated onboard unit. So it's the CAPTCH onboard unit. So when we send the information, broadcast information, the vehicle can actually interpret the information and use it in its decision-making when it's in automated mode, which is pretty cool. We know that not everyone has those. It's been mentioned, there's not a lot of cars with OBUs. So we'll be looking at future stages to adding OBUs to some of the city's fleet vehicles in the real world environment so they can receive it. And some of the companies like Auto Guardian and Fortran use other devices in vehicles such as, tablets or apps on phones to send their safety information. We're also looking at putting a roadside display on the side of the road so people who drive older cars like me can see dedicated safety messages. So this kind of talks a little bit about the 3 different domains that we're looking at. Really important, I think we've heard DSRC, we've heard cellular. We're actually testing the information going from the roadside unit. It's a hybrid RSU, so we'll be testing, latency, band loss. We were using spectrum analyzer technology from ThinkRF. We'll be testing over 5G, 4G, and DSRC. So sharing all of that information into the safety pool database internationally and looking at, what is the distance, what's the throughput, what's packet loss on some of these different technologies in different settings and different seasons as well. Let me just go to the next slide. Sorry. So again, this is, there's quite a few technical people on the call and I'm happy to do any follow-up, but we really are taking, the roadside unit on the side of the road, and we're adding all kinds of different machine vision sensors. We're using the CMCC from CAPTCH and others. We're working with MH Corbin and their controller. So really, and providing all this data from these machine vision sensors, it's available for companies to use as well. And I think that's an important differentiator on all the work that we do. It's always focused on SMEs and SME commercialization and growth. We have another project, fingers crossed, we should hear shortly if it's successful in Transport Canada, which is for rail safety. What's really interesting about this is that if you can see the picture on the bottom left, that smart intersection that Omar was talking about, it's about 800 meters just straight up the road from this at-grade crossing that we're focused on. So we'll start to look at RSU to RSU communication. So very interesting. Siemens is a part of our rail proposal. If we're successful, we have 10 different companies in here. It's a long project. It's 2 years. A lot of machine vision work will be looked at when we're looking at what's going on at these intersections so that we can probably find out lots of interesting things. One of the use cases, it's actually with City of Ottawa. We have an existing project with their snowplow group, but it'll be to broadcast a message to the snowplow that they're approaching an at-grade crossing. So we have 67 at-grade crossings in City of Ottawa. This is a big one for us. It'll actually trigger the development snowplow to lift its blade ever so slightly as it crosses over the at-grade crossing. So we're excited about that work. And then of course, our vehicle and other city vehicles are a part of this project. Well, they'll be fit up with OBUs as well. I think that was it for me. I think if we're successful here, Kat, I have a closing video. So fingers crossed.
A smart intersection is a safer intersection. It's an intersection that is connected to smart city systems and provides the city with enhanced capabilities they can deploy to improve traffic control. These powerful emerging technologies can help keep vulnerable road users safe, help manage traffic congestion, help keep transit vehicles on schedule, help first responders get to their destinations faster, and reduce harmful greenhouse gas emissions.
One of the important things that, for example, at the City of Ottawa is we have 1,200 signalized traffic intersections, and safety is paramount for us. So with the cars of the future and as technology grows, the ability to understand how to improve the safety of vulnerable road users is really important.
The Safe Smart Intersections project is really focusing on protecting vulnerable road users by using technology to detect vulnerable road users as they move through the intersection and coordinate their movement with advanced alerting and notifications to the vehicles surrounding those pedestrians and cyclists.
What we're doing is we're helping Transport Canada strategically to provide enhanced road safety. So at the highest level, that's what they're trying to achieve.
Of course, we're doing this very carefully, and of course, we're also doing this on the heels of a very successful trial in the living lab.
Our project in particular is looking at machine vision sensors, ITS sensors, so that includes things like camera, LiDAR, radar, thermal, and detecting the actions and monitoring pedestrians around intersections. We then broadcast that safety information over DSRC and cellular to vehicles that can receive it. So then the vehicles can use the information to make decisions. And we're also going to be looking at, we know not every vehicle today is outfit with, the integrated onboard units that can accept these messages. So we'll be looking at other modes of transmitting that safety information to vehicles. So through cellular phones and displays, and as well by roadside display.
The duration of this project will span across 9 months, so we'll be able to touch multiple seasons as we go on. This is where the road sensing technology comes in, whether that be snow, sleet, rain, or just sunshine. We'll see how these sensors react to different weather conditions.
As we go along, as findings come in, improvements can be made in an iterative manner so that by the time the project concludes, advancements can actually take place in the technology and in the learnings and findings.
To me, the key thing is unlocking the data that sits in the city and making it available for actionable use. That process of connecting vehicles to smart city infrastructure and using the available live, real-time data is extremely valuable.
This testing is extremely important, so important that the data from this test will lead to recommendations and also find it itself into the University of Warwick's safety pool, so that everyone can actually tap into and make this market safe.
We're glad to see our earlier work on autonomous vehicle governance being used in joint ventures. Ottawa's Smart Safe Intersections for Vulnerable Road Users project is a great example of the power of actionable data gathering, knowledge brokerage, and continuous iteration among actors from around the world.
Another really critical component of the project is we're starting to introduce security and security monitoring of the infrastructure. So in partnership with BlackBerry, their Certicom division will be deploying a secure credential management system, or an SCMS, into the roadside unit and the onboard unit, enabling the vehicle to do that secure handshake with the intersection, ensuring that the information is secure, encrypted, and actionable.
We're taking the latest and greatest of our artificial intelligence technologies, our wireless technologies. We're really stretching our technical abilities.
So what we're here to do is mature our technology platforms even further and take insights and learn all our lessons from all the test activities that we perform here.
This project is a great way to test and validate technology, not just ours alone, but being able to work with so many different providers up on one pole in a public test bed to really validate that real world experience is vital.
We have a lot of different stakeholders involved and unifies kind of the mission and the goal for all of us to find ways to solve the problem differently.
Through this collaborative environment that we have, we can actually showcase and demonstrate, all these different technologies together and see what are actually the advantages of these technologies and how these technologies can be eventually deployed in a larger scale within the urban environment.
Ottawa is already sort of internationally recognized as the R&D capital for communication technologies, mobility technologies, and these are at the core of the work that we do. So anything that we can do to continue to showcase and advance these capabilities, I think is good for all of us.
Really what excites me is the ability to change the world. And here at Area X@O, and with a partnership of all the different project partners, we really have the opportunity to start to do that.
And this is only the beginning. This is only the starting point. And this technology is going to drive us through and drive forward our future for a safer and more sustainable way for our cities to operate.
We are a little over time, but I will open the floor if maybe one or two questions are burning and you'd like to ask Kelly or Omar. Just raise your hand or you can type it in the chat. Okay, maybe I'll jump in with one here. So this one is for Kelly. So based on the project you've done so far, what would be your main recommendation or advice to help municipalities plan for the adoption and deployment of smart mobility?
So I think I've heard it in a lot of the lessons learned here today, but I think that this is bigger than just one municipality. I think we all need to partner together and share lessons learned and, you know, share concerns and share strategies and frameworks in order to really advance this as a province and a country. And like I said, we're funded by OVIN, we're funded by the federal government. The private test facility is here for people to use. We'd love to work with more people. We're very open and collaborative. All the data we collect, we're quite willing to share. And I think Omar would echo that. So I guess the biggest recommendation I would have is that it's not any one of us, it's all of us together. And how do we collaborate even better? Like I said, for me, that was the first presentation I saw in the full MTO project. It's stellar. I think there's lots of opportunities to collaborate there and build on that work. And we, of course, work with Hamilton, but I think just always having each other at the table so we can, you know, do this bigger, better, faster, and safer.
Yeah, I definitely agree with that. And then there's a question in the chat for Omar, so I'll shoot that over to you. Can you explain the local regulation you have in place to require the city's approval for on-road testing and how that overlaps or interacts with the Ministry of Transportation's AV pilot project? And that's from Jennifer Neese.
Yeah, so it's a good question, and probably it's a longer answer. I mean, so, you know, the AV pilot project includes everything from, or what looks like to be including everything from sidewalk robots all the way to the full automated vehicles. And we, as a city, I mean, we are 20% urban, 80% rural. We have a large farming community and so forth. And so there's a number of different opportunities. Everything obviously that we do, we have to follow any of the rules within the AV pilot project. But where the municipality has the capacity of implementing local buy-in or local rules, we've gone through the process of putting together bylaws to require what we feel is important for an agency or an organization who wants to be able to test. And that allows us to have some of that sort of final control over whether or not, you know, they have to meet a certain requirement, for example, you know, making a continuously audible sound and so forth. So it's almost always it'll be required for us, at least if there's a municipal control or buy-in off of that, that we will have I'll call it a permit process, for the lack of a better word, where people have to apply and we will verify that we feel safe with the vehicles on the road.
Yeah, I would just add, so our autonomous Lexus, so with COVID, we haven't applied to the program for a permit to run in autonomous mode on public streets, but we'll be doing that shortly. So for the MTO team, stay tuned.
Great. Well, thank you both again for presenting and joining us today. So I think in the interest of time and trying to get everybody out of here in time for lunch today, we'll move on to the next presenters. So the next one will be a little bit shorter, back to the Ministry of Transportation, but this time the Emerging Technologies Office, Adam Rosenfield, and he'll be speaking about the new transit technology toolkit that MTO has pulled together. So over to you, Adam.
All right, thank you, Kat. I'll just share the deck here. Awesome. All right, good morning, everyone. And thanks for sticking around for the final talk. For this presentation, we'll pivot a little bit from the discussion on V2X to a bit of a broader outlook on the future of how technology can improve public transit. My name is Adam Rosenfield. I'm from the Ministry of Transportation's Emerging Technologies Office. And we're excited to share a project we're working on right now called the Transit Technology Toolkit, as mentioned earlier by Associate Minister Cho. So for a bit of background, last fall, the government released the second phase of its automotive strategy, Driving Prosperity, which included a commitment to foster innovation across the transportation sector. And one of the focus areas is public transit. And the idea for this toolkit is that it will be a public-facing guidebook to help Ontario's transit systems in particular, some of the more small and medium-sized and more remote municipalities, as well as Indigenous communities, to help better understand, assess, plan for, and where appropriate, adopt new transit technologies. So for today, we'll give a brief overview of the project and seek your input by way of a few prompting questions at the end. So in a nutshell, the toolkit aims to be a resource to support Ontario's smaller transit systems with tools to help ensure that their transit systems can remain efficient, accessible, and competitive. We're focusing on smaller and medium-sized communities given some of the resourcing challenges they may face. And our objectives are threefold. So first, we want to help build awareness of what's out there, both existing and emerging transit tech. The second is about identifying some approaches that these transit systems can use to help grow their ridership, expand both their service and geographic coverage, and find ways to enhance the experience of riders. And the final objective ties in an economic development lens and really looks at how we can build connections between the transit sector and Ontario's technology sector, identifying homegrown innovation. So the areas of focus will include some case studies on how emerging technologies have been adopted by transit systems at home and abroad. And it'll be written in non-technical language with the aim of providing kind of a menu of options with instructions for implementation in areas like service planning, customer experience, operations, and capital investments. So I want to get to some specific examples here of what some of the actual tools in the toolkit might include. And we're still in kind of early days, so this is somewhat illustrative, but some potential tools may include an index or repository of resources for things like training and skills development, sharing of best practices, pitfalls, lessons learned from case studies of technology deployments, decision-making tools for assessing if and when certain technology deployments might make sense, tools for developing cost and budget estimates for acquiring and operating these technologies, resources to help point to funding opportunities and support with grant applications, as well as things like strategies to ensure the successful implementation of either pilots or permanent technology solutions. And then some other resources like sample frameworks for requests for proposals, specs, and proposal evaluation tools, as well as potentially technology vendor lists and spotlighting perhaps Canadian and Ontario-based companies where they exist. And finally, some foundational tools like explainers of terms, concepts, and categories of what technologies are out there. So right now, we're in the midst of developing the toolkit with the aim of complementing related initiatives and guidebooks. So we brought on a consultant called Left Turn, Right Turn to help us prepare the documents. And we've undertaken some early engagement with several communities already. And we'll be engaging all of you more widely once we have an initial draft toolkit prepared, as we really want your input and feedback on what aspects are most useful and where there are gaps that we can work to fill. So at this point, I'd like to actually stop there and pivot to some discussion questions, just because I know we have a diverse set of communities represented on the call today. So I'd encourage you all to use the chat as we do this, and I'll open it up so I can see this. But maybe just to start, it would be great to kind of discuss what technologies are currently being implemented by Ontario's transit systems, or those worth exploring to help improve transit. So maybe we can just take kind of 30 seconds to type some ideas into the chat. So these can be technologies either your municipality is implementing or ones you're aware of in other areas. It can be customer facing or kind of back-end systems. And then maybe we can call on some folks to share some detail on that. So maybe just take a moment on this question. And if folks want to raise their hand as well and just jump in, that's also easy too if it's too much to type out.
I wonder whether there'd be anything on shared services or last mile. Is that a key focus for municipalities? I see there's a comment here as well now.
Mm-hmm. And I want to mention one of the related guidebooks that's being prepared sort of in line, in tandem with this work is around on-demand transit. And so there's a fair bit of work on that aspect, and we'll be complementing that with a look at some of the other areas of technology. But one of the comments here is looking at how V2X can bridge equity gaps, because there's a lot of overlap between general V2X discussion and public transit more broadly. So that's something we'll take back. But I want to also then add a kind of second prompt to maybe look at this a different way, which is what barriers we think some transit systems might be facing when thinking about new technologies. What are some of the challenges? What are some of the pitfalls that they may be running into? Obviously, funding can be a challenge. Technological capacities, resourcing can be a challenge. Curious if there's thoughts from the group on what some of those main barriers might be.
Another one that comes to mind for me, I'm not a transit operator either, but just growing up in the north or north of Toronto anyway, in rural Ontario, is with all this talk about V2X communications and how that's deployed in transit and different things like that. How do we involve rural communities that might not necessarily have that infrastructure in place? So that would be a key one, I would think.
Yeah, and we've got some ideas coming in the chat here. So accessibility being an important one. How do we make sure that technologies are universally accessible? Alignment with funding opportunities, the rapid evolution of technology. This is one thing where often, governments will, by nature, not always be at the forefront. And so how do we stay up to date on these things? And part of the goal of the toolkit is to help the municipalities sort of get a lay of the land of what some of the latest innovation is and how to kind of discern what's more flashy from what's really substantively helpful to agencies. There's a few other great comments here. If there's anyone that wants to speak to these, please feel free to unmute. Yeah, Charlie Cheng has brought up some great examples here. A discussion around digital mobile payments, facial recognition, so fare payment structures, topic commercial vehicles, so hydrogen refueling. There's a lot of innovation happening on the alternative fuels side, so electrification and work around capital infrastructure and planning for a switch to electric buses. So we're looking at that as well. I want to pivot then to the next question, which is around what kind of guidance would be most helpful for you, your staff, your transit colleagues, how the toolkit could be most of greatest assistance. And for this one, I actually want to flip back to slide number 4 of the 9 examples I mentioned. And it would be great if you all want to look at these and just maybe type in the top 3 examples that you think might be most useful. So just like type in like 1, 3, and 7, like into the chat. And we can see what some of you think might be most useful for whether it's your group or your transit colleagues, given that there's a lot of potential tools that we could try to incorporate into this toolkit. And if there's others that aren't on here, maybe throw them out as well, or some commentary on why you made those choices. Okay. Got some comments coming in. Example of a decision matrix of when to adopt the technologies and what kind of resources. Some clarity on the scope of the toolkit, of what kind of technologies we're looking at, because it is quite a broad array of what's out there. And part of what we're doing right now is trying to really scope into what's most useful. Barriers on infrastructure. So what we're seeing that fleet operators are waiting on infrastructure like V2X, chicken and egg. We're certainly seeing that with other areas like electrification. So these are all great examples. And to others, quickly throw in your thoughts on the top 3 examples here. And I think that will be great. I know we're at time, so I appreciate everyone's input. We will keep you all up to date on the progress of this toolkit, and we'll engage this group more broadly again once we have something more fulsome to share. So with that, Kat, thanks so much, and I'll turn it back to you.
Thanks to you, Adam, and thanks to everybody for participating. That's great to see some feedback coming in to help that process. And with that, we're approaching the end of the event. I do want to seek a little bit more of your engagement and collaboration though first. So we'll move on to the next piece, but I'll move through it as quickly as I can. I know lunch is just around the corner now. So I've got some polling questions, and I'd love to get some engagement and feedback on these questions, but just to give a little bit of context on those. So the Ontario Smart Mobility Working Group, which is ourselves at OVIN, the Ministry of Transportation, as well as Metrolinx, we met a couple weeks ago, and we've been doing some workshopping and brainstorming on how we can continue to improve these forum meetings going forward, really provide the best experience we can for members of the forum, as well as start to brainstorm some discussion topics for the next fiscal year. So we tend to hold 4 per year, so quarterly meetings. And so with that in mind, I've got some polling questions just to get some feedback from you all that we can work into as we build out this improvement plan or enhancement plan, if you will. We'll walk you through those. Before I walk you through those, I'll just give some context on the first few questions. So one of the ideas that came to the fold in our brainstorming session was to implement a new process whereby we would have a bit of a living document, and that would be an opportunity for all members to provide updates and information from across different municipalities across the province. And so essentially you'd provide those updates in advance of each forum meeting and provide any inputs you could. So it could be updates on projects or pilots you're working on, challenges or barriers, or I think more importantly, collaboration opportunities or different opportunities to connect with your colleagues. But yeah, it would require a bit of maintenance work, a bit of work on your end in terms of contributing to that. So we wanted to ask some questions around that. So maybe with that, we'll go into the polling questions so we can pull those up. And so the first one, if we culminated updates from across forum members and shared in advance of each meeting, would you consult this and or find it useful to inform your work? And please feel free to be very honest with your answers. And yeah, I see we've got all the polling questions up, so maybe I'll just read through them all and you can at your own time answer them, just to try to keep this moving along. Second one, along the same lines, would you have the capacity or be willing to contribute updates on a quarterly basis to be shared with other forum members? So that one's a little bit more on capacity of your team to provide those updates. And then there's some questions in here in terms of providing a bit more context. So if no, why not? And type that in the chat so we have a little bit more idea on why. And then the next one, as the province starts opening up again, would you be interested in attending an in-person meeting or networking event in the near future? Of course, government regulations and COVID-19 permitting. I think we as a group really think it'd be great to get everybody together. Maybe it's not every quarterly meeting, but maybe once a year, something just to bring everybody to the table and see each other face to face. So that could be something that we look at for either the next one or maybe just in the near future. And then as we start delving into EVs and clean mobility as a topic of discussion, we've got some potential topics that we love your input in terms of which one would be most useful for your teams. So I won't read through everything, but you can kind of read through those. The next one after that, are there any other connected vehicle or autonomous vehicle or other smart mobility topics that would be of interest to explore in a future meeting? And then there's some potential answers there. And again, feel free if there's something else, type it in the chat and we'll make sure that we cover it. Do you have any ideas on how we can enhance the forum and or improve collaboration amongst municipal stakeholders going forward? That one's open-ended, so feel free to type in the chat. And we'll leave this open just maybe for another minute or two, and then you'll be able to see, yeah, you can see the answers as they come in live as well. I'd like to explore applications to good movements and commercial vehicles. Good point, Richard. Yeah, I guess we didn't enable multiple answers to be included in some of the topic ones. So if you have multiples, feel free to type in the chat. Okay, we've got a couple of good topics coming in the chat as well. Most topics would be of interest. That's good to know. So we're on the right track. Yeah, there's definitely no shortage of things we can cover. So we'll take this back. I'll give a little bit more time when I'm going to end the poll soon. Okay, it seems to be calming down a little bit. So I'll go ahead and end the poll. Thank you very much. Really appreciate everybody's feedback and engagement on that. It'll be really helpful as we bring it forward and work to improve this going forward and pull the topics for the next discussions. So thanks again. And if you have any other thoughts after the fact, after the forum's done today, feel free to reach out to myself or the OVIN team, and we'll work that into the planning discussions going forward. So with that, we're now at the end of today's event. So I just want to take one more opportunity to thank all of the presenters who joined us today and shared all your insights and lessons learned with the forum members. Really great to hear from you all. And I hope that everybody else on the line who's joined has taken something from those, and you can really apply those insights as you continue to plan for V2X deployments in your communities across the province. As always, the presentations from today's event are going to be posted on the OVIN website at ovinhub.ca, so you'll have access to those after the fact. And yeah, I think that's it. So I'm happy to close off today's event. Thank you everybody for joining, and we'll see you at the next forum event in a couple months' time. Take care, everyone.